On the previous video, we did power rule and chain rule. Okay, now let's do product rule and quotient rule. Let's begin. We got this form y equal to fg, where y is made up of two functions fg that are multiplying each other. However, to derivate this one, we're gonna use product rule because this is a product. Okay, then the derivative of that will be y prime equal to, here because it's a product rule, we're gonna do it like this. We will derivate the first function keeping the other constant, then we're gonna have f prime g plus, this time around we're gonna keep the first function constant, f derivating the second one, g prime. Yeah, that's the product rule. Then let's have some examples. In the similar manner, to derivate this one, we're gonna use this kind of formula where x squared is f and ln x will be g. Okay, let's name them. F equal to x squared and g will be ln x. Yeah, just like that. However, we have to derivate f and g, then the derivative of f will be f prime equal to 2x, and the derivative of g will be, okay guys, the derivative of ln is y equal to ln u. Then to derivate this one, we're gonna do it like this. Y prime equal to u prime is the derivative of ln divided by u. Yeah, just like that. Then however, in place of u, here we got x, meaning that we will derivate x and the derivative of x will give us 1, then divide it by x. Okay. Then g prime will be 1 over x. Using this formula, y prime equal to f prime g plus f g prime, then we're gonna have y prime equal to, our f prime is 2x keeping g constant, then we will have ln of x plus, this time around we keep f constant, then our f is x to the power 2 times the derivative of g, which is 1 over x, then we will have 1 over x. Yeah, just like that. Now for the sake of practice, let's have this one, y equal to x cubed e to the power 2x, meaning that we will derivate this one using this kind of formula. Since we have two functions, just like here we have f, g. Okay, we're gonna let f and g, then f will be x cubed and g will be e to the power 2x. Yeah, just like that. Okay, let's find f prime equal to 3x to the power 2, and the derivative of this one is To derivate y, we're gonna do it like this. It will be y prime equal to u prime e to the power u. Yeah, just like that. Then in our case, u, the whole of u is 2x. Then to derivate 2x, we're gonna get 2. Then g will be g equal to 2e to the power 2x, just like here, meaning that u is 2x. Then we're gonna have 2x here, just like that. Then now we can use this formula, y prime equal to f prime g plus f times g prime. Then we're gonna have y prime equal to, then we will replace f prime by 3x squared, then multiplied it by g, and g is nothing but e to the power 2x. Then we're gonna get e to the power 2x plus f, the original function, x to the power 3 times the derivative of g, which is 2e to the power 2x. Okay, just like that. We can factor out x squared and e to the power 2x. Then we're gonna get x squared e to the power 2x. Inside the parenthesis, we're gonna get 3 plus, here we will be left with x and 2. Then we're gonna get 2x, just like that. What if we have more than 2 functions that are multiplying each other? Then to derivate this one, we're gonna do it like this: y prime equal to, we will derivate first function keeping the other constant. Then the derivative of 2x is nothing but 2. Then keeping this constant and sin x, plus this time around we're gonna derivate ln x. Then we will keep 2x and sin x constant. Then we will have 2x. The derivative of ln x is 1 over x. Yeah, just like that. Sin x plus, this time around we're gonna derivate the last function, which is sin x. Then we will keep 2x ln x constant. Then the derivative of sin x is cos x. Let's check out quotient rule. However, quotient rule, it has this form: y equal to f divided by g. Okay guys, we use quotient rule if and only if we have fraction. Just like here, we have f divided by g. Then to derivate y, we will use quotient rule. Okay, let's derivate y equal to, then to derivate y, we're gonna do it like this: we will keep the denominator constant, the denominator g, and derivating f. Then we're gonna get g times the derivative of f minus, then this time around we will derivate the denominator g prime keeping f constant, f, and divide by g squared. Yeah, just like that. Okay, let's get some examples. Okay, we have this example, y equal to sine x divided by cos x. Then we will name them. Our f will be sine x and g will be cos x, but the derivatives of them will be f prime equal to the derivative of sine will give us cos x, and the derivative of g will be negative sine x. Yeah, just like that. Then we're gonna replace our derivatives in this formula. Okay, we will have y prime equal to g as it is. Then we have g is cos x, and the derivative of f, which is cos x, and the sign in between is negative, minus the derivative of g, then into minus sine x, just like that, times f is sine x, then we have sine x, divided by g to the power 2, and g is nothing but cos x, then we will have cos squared, yeah, just like that, x. However, this is the same as on the numerator we have cos and cos will give us cos squared, negative and negative will give us positive, and sine will give us sine squared. Then the numerator will become 1. Then we will have 1 divided by cos squared x, just like that, which is equivalent to secant squared. Yeah, that's it. This is the last one. Let's derive this one by using quotient rule. Then the derivative of this one will be y prime equal to, we will keep the denominator as it is. Then we have ln x, and we will derive x, but the derivative of x is 1. Then we will have 1 minus, this time around we're going to derive ln x, but the derivative of ln x is 1 divided by x, and we have to keep f constant. F is x divided by ln squared, then it will be ln x to the power 2, yeah, just like that, which is equal to, here we will be left with ln x